Right, 4.3 binomial distribution. Last problem here. It says during the 2013 regular NBA season, DeAndre Jordan of the LA Clippers had the highest field goal completion rate in the league. DeAndre scored with 61.3% of his shots. Suppose you choose a random sample of 80 shots made by DeAndre during the 2013 season. Let X be equal to the number of shots that scored points. Yeah, 61.3% is incredibly high. But I'm not a basketball person, but I think that's pretty notable. Alright, so with that, part A. What is the probability distribution for X? We're going to say it's binomial, but verify that's a binomial experiment. Here in this case, DeAndre had 80 shots. The probability that it is a success versus non-success, making that, quote, binomial, or bi there. The P there for that percentage for success is 61.3%, 0.613. And the complement of that, is 0.387. Again, 1 minus that number. Take any calculator here, you can verify that. I'm going to grab a little calculator here, switch that over to, there we go, 1 minus P, 1 minus 0.613, there you go, 387, so 0.387, that is Q, that's where that comes from. But of course I don't even use that next door over here in the GeoGebra calculator, but we'll grab and need it in a later section, just not right now. Here X is 0 up through 80, 0 representing that no shots out of the 80 are made, or 80 representing that all 80 were perfect shots there. Okay, so that is a binomial experiment, either makes or doesn't make the shot. For the field goal, part B, using the formula there, calculate the mean and standard deviation, those parameters there for random variable X. Let's scroll here a little bit. Oh yeah, look at that. Mu there, the formula for that is N times P. So all we're going to do is, let me grab my little friendly calculator here. Here we go. Let's slide that there. Alright, 80 times 0.613, 49.04, and rounding that to one decimal place would be just 49.0 shots. Like all the normal rules of rounding, because we're dealing with whole numbers, we just need to round the parameters to one place. If you wrote down the whole number, 49.04, that would be absolutely fine, because that is a terminating decimal, non-repeating. But however, get something a little different here for part 2, part B there. Sigma, the formula for sigma is the square root of N times P times Q. So here N is 80 shots, probably a success, 61.3% or 0.613. And its complement determined up above, 0.387. Alright, going to grab a calculator here, multiply, then square root 80 times 0.613 times 0.387 gives us 18.97848, and then you hit the square root button, round that to one place there. So 4.356, or in other words, we're looking at 4.4 shots for the population standard deviation. So if that was not a binomial experiment, you'd have to do all that by hand using the PDF over here. Alright, let's go to part C and part D. Okay, what's part C here? Let's see. C for part C. Use your calculator to find the probability that DeAndre scored with 60 of these shots. So that is exactly 60 out of the 80. No more, no less. So that's where we're saying that the random variable is equal to 60. Jumping back over here, changing those parameters. And by the way, if we set everything up here, we have the 80 shots, the probability of success, 0.613. You'll notice that at the top here are the parameters, the mean and the standard deviation, 49.04 and 4.3564. Both of those rounded to one decimal place. All right, grabbing this we want for exactly 60. There we go, we did it. If I scroll here, it is right there on 60, done. So he has to make exactly 60 out of those 80. This is a lot there. He has a 0.0036 or 0.36% chance. Not a very good probability. But the most out of the 80 shots he could expect is 49 of those, because that's the peak there at that probability. If you notice here at 49, up there, looks like that's your peak there at 9.12%. So 9% is the greatest probability out of the 80 shots there, pinpointing that 49 would be the expected value, the expected number of shots made. Alright, part D. Let's do that. Find the probability that DeAndre scored strictly more than 50 of these shots. More than 50 would be the first number. More than 50 would not include that. That'd be 51 or more. So that is using the left bracket. I'm going to go to the left and of course change that to pointing the left direction there. You notice the inequality arrows are pointing to the left, and the bracket is, in that case, facing to the left. So we have to start off with 51 because we want strictly more than 50. And once you type that in there, you're going to grab over here, put your cursor there at that bottom right box. There it is. There. Bam! 0.3718. So the probability that DeAndre can score more than 50 has a 37.18% chance of that happening. So that is part D on using the GeoGebra calculator and the aspects of that to answer a binomial question with binomial probabilities and a binomial experiment. Okay, it's been good.